Right, we will come to the next one, people, the limits parts we discussed. Then here today I supposed to discuss the differentiation part. Differentiation. Is heading. Right. I am going to consider its subheading as a definition of the derivative. Definition of the derivative. Definition of the derivative. Right. People, to explain this, I'll take this way. The graph is the x-axis, is the y-axis. I'll take the graph this. The graph is y equals x square graph, right? This y equals x square graph. Right. The equation of the graph is y equals x squared. You know, in our quadratic equation lesson, we drew this graph of y equals x squared. It is a minimum graph. The minimum point occurs at the origin, right? This way a graph. People, I am going to consider there a point on this graph. The coordinates of that point I'm going to take as point is P, coordinates xy. This xy two values are, people, x is like 2, y is like when x equals 2, y is 4. Such point only I am considering here as pxy. So therefore, since I need to take this point P as in the most general form without giving particular values 2 and 4 like this, I take x and y as the coefficient, as the coordinates, people, right? So this x means, people, really, when I drop a perpendicular like this to the x-axis, x means this length, and y means this height. Okay, right. Now what I do next is, people, I increase this x value we took as 2, no? I increase this x value. I increase this x value by a very, very, very small value like this, 0.000001. By a very small value, I increase this present x. Then the new x going to be 2. To this 2 only, I am going to add this. Now, this value of x by which we are going to increase our present x. Present x is 2. This x I am going to increase by this value. People, this is a small value in x. The small value of x we denote by the symbol this way, delta x. We have another letter for delta. It's a triangle like this. That way also we sometimes write this. But I am writing it like this, delta x like this. What is this delta x? Delta x means very small value of x. The delta stands for very small. Then delta x is very small value of x. So that value, very small value of x is this much, people. Very small value. So now, when we increase the present x by this delta x, our new x value going to be, people, x plus delta x. X plus delta x. So therefore, the increment of x is here delta x. Increment of x is delta x. If I try to show, people, this small increment in this graph, we can't show the gap between x and adding that very small part of this x. The gap is very narrow. So therefore, you can't clearly show that. Right? Now this is, I am going to show by people this kind of very small value delta x, right? Delta x is very small, but in order to get a clear picture here, I have expanded this, what people, small value this much, that way. Okay, otherwise the delta x, when I try to mark this figure, when I try to mark here, it's a very close value to this that you can't see. So then I take that delta x like this. Now people, this is the increment of x. Then you can very clearly see here, right? Now the new value of x going to be x plus delta x. New value of x going to be x plus delta x. For the new x value, when I try to find the corresponding y value, right? This is the graph y equals x squared, right? This is the new y value. For the new x value, right? This is the new y value. The earlier y value was people this height. Initial y value is this. That is this height, no? Now extra increment of y we can see here, right? This extra increment of y occurred due to the increment of this x by delta x. X has been increased by delta x, people. Due to that only this extra y value this increased. So therefore this increment of y we therefore denote by delta y. Understand, right? Because that is a small increment in y. Then you can very clearly understand, people, this new y value is going to be y plus delta y. Y plus delta y. Now this delta y and delta x are called as increments, right? This delta y and delta x are called as increments. Increments. Understand? Okay. Now you can very clearly understand this point after increase in x by delta x, y increased by delta y, then this point has the coordinates, people. Its x coordinate is x plus delta x and y coordinate is y plus delta y. I think up to here you can very clearly understand. Okay, right. Now you can very clearly see there are, people, this point P and this point I am going to take as Q. This point I am going to take as Q, people. The point P has the coordinates xy and the point Q has the coordinates x plus delta x, y plus delta y. Both the points P and Q lie on this graph with the equation y equals x squared. You know, whenever any point lies on a particular graph, then that coordinates of that point should satisfy the equation of the graph. It means, people, when I consider this point P, its x coordinate is x, y coordinate is y. Point P is on this graph. Equation of the graph is y equals x squared. Then satisfying the coordinates mean this x value, when you put for the place of x in the equation, y value for the place of y, the left hand side and right hand side still being equal. That is called as the coordinates of the point satisfy the equation. So therefore, people, we can write, okay, we can write here for the point P and for the point Q, since those points P and Q lie on this graph with the equation y equals x squared, we can say the coordinates of point P and point Q should satisfy this equation. Understand, right? Then we can write like this. Since the points P, x, y and qx plus delta x, y plus delta y, right, lie on the graph y equals x squared. What can you say, people? First thing you can put here x and y for the places of this and this. Then the same y equals x squared coming, no? Y equals x squared. Number one. Secondly, people, that x plus delta x we put where here, y plus delta y we put where here. There, after substituting that, still the left and right should be equal. Then y going to be y plus delta y, x is x plus delta x perfect squared. This is number 2, right? Now what happens, people? What we do is we take 2 minus 1. We take 2 minus 1. When you take 2 minus 1, here y plus delta y minus y come into the left hand side. Right hand side, people, x plus delta x minus x squared coming. The left hand side you can simplify this 2, you can cancel down. Delta y coming. Here, when I expand this you can expand by using a plus b perfect squared. You know, people, the expansion of a plus b to the power 2. A plus b squared this, right? A plus b squared is, people, it is a squared plus 2ab plus b squared, no? Using that, when you expand this, what we get is x squared plus 2 times x times delta x plus delta x perfect squared minus x squared. People, here in this simplification, here you have 2 into x into delta x. People, especially this x into delta x, when you write, people, remember that you can't multiply this x and this x. And multiplying them, you can't write it like this. This is wrong. This delta x stands for what? Delta x stands for very small value of x. And when we multiply such small value of x by this x, if we write this way, this says change in x squared. Delta stands for change or increment, little value. That is the meaning of delta. Delta x squared means a little change of x squared. So here left hand side, little change in x multiplied by x will not be equal to little change in x squared. So therefore, remember, x and delta x, when you multiply, you can't write like this. So then x into delta x forever like this. Remember that simplification, x into delta x forever like that. Furthermore, there is no any other way of writing x into delta x. And the other thing, people, here, this delta x squared, sometimes you might think, what if we write this delta x squared like this, delta squared x squared? This also people want to write. Okay. Forever this delta x squared, you can't separate this delta and x as 2 letters. Delta and x as one single letter. Their delta stands for small change in x. So therefore, delta x squared also you can't write like this. Okay, right. So now, what I can do here is, people, x squared and this x squared you can cancel down. Then we have delta y. Now what we secondly do, we divide both sides by delta x. When we divide both sides by delta x, we get delta y upon delta x. It is equal to what? Right hand side 2x delta x plus delta x perfect squared. We divide the right hand side by delta x. Therefore, I can write it like this. Okay. Now I can do the simplification like this. People, this delta y by delta x is called as, here we have a fraction. Fraction means a ratio. Then this delta y upon delta x is called as the incremental ratio. Incremental ratio. It is called as the incremental ratio. You should know these specific words we use, right? Incremental ratio. Okay. Now, people, on the right hand side, we can simplify. You can take, here delta x squared means delta x multiplied by delta x, no? You can take here delta x and this delta x out. That delta x at the numerator and this you can cancel down. Then what happens? One delta x here will disappear. This delta x will cancel off and this delta x will cancel off. Then for our incremental ratio people, we get like this. Delta y upon delta x is therefore equal to 2x plus delta x like this. Understand? 2x plus delta x. Then finally, after coming to this incremental ratio delta y by delta x, understand people, we take the limit of delta x 0 on the both sides. We take the limit delta x 0 on both sides. Okay. So now we can write take in limit delta x 0, right? There what you get. Okay. Limit delta x 0, delta y by delta x, limit delta x 0 here, right hand side 2x plus delta x. Now on the right hand side, this delta x going to 0, we apply on this x and this delta x both. Okay, so then I can write it. And the other thing is people, here the left hand side, delta y by delta x is called as the incremental ratio. No, in that incremental ratio, the denominator delta x going to 0 here. That occasion people, this limit delta x going to 0, delta y by delta x, this whole thing, with this limit delta x going to 0, we denote by people dy by dx by a new notation. Understand? So this is denoted by dy by dx. Dy by dx. So limit delta x going to 0, delta y by delta x people, we denote by the notation dy by dx. Dy by dx. Okay, it is called as the derivative of y with respect to x. Derivative of y with respect to x. What? That dy by dx. So then I can write for this one dy by dx. So people remember, whenever we write dy by dx for something, that thing should be in the form delta y by delta x. This is the incremental ratio. The denominator should go to 0. Then for that thing only, we write this one dy by dx. Okay. This stands for derivative of y relative to x. Dx means relative to x. Why do we hear the word relative to x? Relative to x means people initially taking this kind of point, its x coordinate is x, we increase x by delta x. Initially we increase x by a very small value delta x. So that is why here we say relative to x. Now when I take here on the right hand side people, limit delta x going to 0, 2x here. And the other one is people, limit delta x going to 0, delta x. Understood? Right. People, now what is meant by this delta x going to 0? Delta x going to 0 mean, you can very clearly understand, delta x means this size, no people. Delta x means increment of x. Delta x means increment of x. That increment of x is this. It is going to 0 means people, the gap, the delta x begins from here, no people. Beginning here, ending here. Delta x going to 0 means people, this right hand side, this dotted line, this gap reduces. This gap reduces. This gap reduces. When this right hand side, this dotted line gradually coming towards this left, what happens? This delta x reduce into what? 0. One occasion, this dotted line coming to left like this and comes on to the left hand side vertical dotted line, exactly this delta x equal to 0. But people, you know, under limits lesson we discussed, delta x going to 0 doesn't mean that delta x will be equal to 0. There, when you very carefully watch those recordings, you can see I said, but x going to 0 doesn't mean that x will be equal to 0. x going as much as closer toward the value 0, but it doesn't take 0. Like that, people, delta x going to 0 mean this gap as much as possible decreases. That means this vertical dotted line and this vertical dotted line, they come closer to each other, but they never overlap. Right? Then you can see once this gap decreases this way, people, you can see this x1 change. No, this gap only decreasing maximum up to here. This line, vertical dotted line, never come to this position. Then this x1 change. So therefore, you can very clearly see here 2 into x never change due to this delta x going to 0. According to this diagram, you can see this x1 change, though this delta x going to 0 this year. Look at this. This length never change. Therefore, no effect to this 2x by going this delta x to 0. Therefore, this will be 2x. And people, this one, what happens? The same thing only here going 0. Then delta x going 0. Here also we have delta x. Then this is gradually coming to 0. So then we can write the final answer dy by dx as, people, this one change 2x and this will be 0. Then we get the final answer for dy by dx like this, 2x. Okay. But people have a y. Y was this, people, here. Y is x squared. Therefore, I can write substituting for this y. This gives us d upon dx. D upon dx. What is y? Y is that x squared. Right? It is, people, 2x. So therefore, how do we read this? Derivative of x squared with respect to x is, people, this 2x. Understood? Right? This is how we find the derivative for the function y equals x squared. Okay, right. So then if I summarize the situation I have used so far, people, I considered the graph of y equals x squared. It's the minimum graph. We drew this kind of graph here in the quadratic equation lesson. The minimum point occurs at the origin O. Thereafter, I consider a point on the graph with the coordinates x, y. Understood? Now, the x value I increased by very little value called as delta x. Delta x means very, very, very small value like 0.00001, like that. Such a value only this delta x. Therefore, by using this kind of gap, when we try to represent that, that is unfair. But people, fairly, we can't show such small value on this diagram. You can't see that clearly. So for our convenience of seeing this, I mark this delta x, very small value even though, by this gap. Then x has increased by delta x. Now the new x value is, people, x plus delta x. This is the new x value. Then from there, when we draw a vertical line, you can see the corresponding point on the graph is q. Earlier y value was this. And in addition to the early y value, another extra y value added. That extra y value is the increment of y. It is denoted by delta y. Then this increment of y, delta y, occurred due to the increment of x by delta x. So therefore, the new point on the graph is q. Its x and y coordinates should be, people, x plus delta x. This is the x coordinate. Its y coordinate is y plus delta y. Understood? So now both the points P and Q lie on the graph with the equation y equals x squared. Understand? So therefore, the coordinates of the points P and Q must satisfy the equation of the graph y equals x squared. Coordinate satisfied means what, people? For x, we substitute x coordinate. For y, we substitute y coordinate. Then the left and right become equal. That is called as what? Coordinate satisfy the equation. Now, like that, I wrote these two equations, and thereafter we subtract this number 1 from number 2. I found delta y like this, and both sides I divided by delta x. Then we get delta y by delta x to left hand side. This is called as what, the people? Incremental ratio. Now in the incremental ratio, I took delta x limit 0. on the both sides. Then to the left hand side, we get limit delta x on 0, delta y by delta x. This one, of course, we denote by dy by dx. See here, to write this dy by dx notation, what should we have? We have, people, delta y divided by delta x, incremental ratio, and its denominator should go to 0. That occasion only for the whole thing we write dy by dx. This is called as what? Derivative of y with respect to x. On the right hand side, once I take this delta x 0, I have take the delta x 0 for this and this separately. Once you take delta x 0 here, we have 2x. This x won't change though this delta x going 0. The reason delta x going 0 means this end coming closer to this right hand side, the vertical dotted line coming closer to what? This left hand side dotted line. Why? This gap only we denote as delta x. Then delta x going 0 means this right hand side dotted line gradually come into what? This left hand side dotted line, but the two dotted line never be coincident. That says, people, though this come in this way, this x doesn't change. Therefore, though this delta x going 0, x won't change. But here we have delta x, right? As delta x going 0, this will be 0. Therefore, that place will be 0. I put that here. Then we get dy by dx as 2x. Y is that x squared. Therefore, put y x squared like this, and then we get the derivative of x squared with respect to x as 2x. People, that is how we find the derivative for a given graph. Then you might think, what is the meaning of this one and why do we do like that? Don't ask those questions. First, understand these steps. Thereafter, we can answer your all doubts. Understand? Right now, before going to give the common definition for this, first of all, we'll take down this, and thereafter I will give you what, people, the definition for any function. Take in the right hand side in place of this x squared, any general expression in x as fx. I'm going to develop what the same thing again. Okay, right, people. Then we can write like this. Write down like this. Consider the graph. Consider the graph of the function y equals x squared. Y equals x squared. Right. People, now first draw this whole graph, including everything here I have put. Draw everything here, the graph. We will explain one by one below this graph, right? So therefore, we have to draw the graph, marking everything they are available. So then I will cover the thing that you must draw here. This only you must draw now. Right. Okay. Draw that one first and mark everything. I think you can see clearly, no? Right. Draw only this graph. Everything you have to mark there. I have marked down. Right. People, now we shall take down some notes. Right. Take down some notes. Okay, people. Write down. Consider a point. Consider a point capital P within bracket x comma y. Capital P within bracket x comma y on the graph of y equal x squared. Y equals x squared. Now write down. Let's increase simple x. Let's increase simple x by a very small value. By a very small value delta x. By a very small value delta x. Due to the increment of simple x, due to the increment of simple x by delta x, we can see by the graph, there is an increment of simple y by a very small value, delta y, by a very small value delta y. By a very small value delta y. Now the new point on the graph B capital Q, then coordinates of capital Q are within bracket write down x plus delta x comma y plus delta y. Now since the points P and Q, lie on the graph lie on the graph y equals x squared y equals x squared. The coordinates of the points P and Q should satisfy the equation y equal x squared. The equation y equal x squared. Right. And then people write down this equation number 1 and this equation number 2 and take in 2 minus 1, find delta y and dividing both sides by delta x, come up to here and don't write after that anything, right? Come up this delta y by delta x, don't write anything after that. Okay, come up to this. Okay, people? Now write down like this. Write down like this. Start from new line. The ratio delta y upon delta x, delta y upon delta x is called as incremental ratio. Incremental ratio called as incremental ratio. Now write down under that, after that, take in limit delta x 0, take in limit delta x, put arrow 0 on both sides of the above result, right, people? This and this. Thereafter, take up to here and come up to this. Right? Yeah. Come up to the last result, this. Come up to the last result, this. Thereafter, we have to write something. Okay, right, after reaching this, now you must write another sentence. It is this: here, right, after reaching here, write down here, limit delta x going to 0, delta y by delta x is equal to dy by dx, is equal to dy by dx. Put another equal sign here and write put equal sign here and write the derivative of y with respect to x, the derivative of y, the derivative of y with respect to x, the derivative of y with respect to x. Understood, people? Right. So this is how simply we define the way of finding dy by dx. Now I am going to give you, now here people, here we use the specific function as x squared. No, the right hand side of this graph can be any expression in terms of x. Then I am going to give you the definition taking this right hand side as any function. Here we did for x squared, but we should know whatever it is available here for that thing, how to do this. Then I am going to take people this right hand side instead of this x squared, I am going to take that as fx. I am going to take that as fx, right? Taking that as fx, now I am going to give you the definition. Then the right hand side is, this is fx now, right people? Right. Okay. Now we can write it like this. People, now without drawing this whole thing again, I can very easily give you the definition like this. People, now here, this place is fx, no? Right. This place is fx. Then this x and this y we substitute where? Here and here, no? Then again we get y equals fx. Right. Then this is number one. What is the second one? To the left hand side we have to put y plus delta y. And this x only, now we have replaced by what? X plus delta x, because we said what? This x plus delta x should be substituted for x, y plus delta y we have to substitute for y. Then this second equation will be, people, this f within bracket x plus delta x. This is number two. Now we take, people, the difference. Okay, right. Then we can write by erasing this all, write down this way. Write down like this. The definition of dy by dx, definition of derivative. The definition of derivative for y equals fx at the point px comma y. Write down like this. px comma y. Right, people? Now, we can actually take for this fx, y equals fx, a graph, any graph, but different shape. The same thing we can follow again. There's no point of following again the same thing. We have the idea. At this place, this is happening. At this place, this is happening. Now, the same thing we can explain, taking this as y equals fx and the same nodes coming. So, therefore, no need to do that again, right? You can very easily understand. So, then first equation comes as what, people? Y equals fx. Second equation, this one. Then we find that delta y taking 2 minus 1, no? Write down like this. By the above result, we can write write down number 1, y equals fx, number 1, y plus delta y is equal to f x plus delta x. Take 2 minus 1, y plus delta y minus y, fx plus delta x minus fx. These two you can cancel now. Delta y equals fx plus delta x minus fx. Divide both sides by delta x. Delta y upon delta x. Fx plus delta x minus fx divided by delta x. Now take the limit delta x 0 on both sides. Now we found the incremental ratio now, people. Taking limit delta x 0 on both sides. What do you get? Limit delta x 0, delta y by delta x, limit delta x 0, f x plus delta x minus fx divided by delta x. This way. People, you know the definition of this. You know the notation for this delta y upon delta x as delta x equal to 0. The denominator thing only going to 0 here, people, under limit. Then this whole thing we write how dy by dx. Very easily you can remember delta y numerator, delta x denominator, delta x should go to 0. Then this whole thing we write as dy by dx. How? Writing for this delta the letter d, dy divided by dx, right? Dy by dx. So therefore, people, this is how we define dy by dx, first derivative of y with respect to x. Then on the right hand side, what do we have, people? Limit delta x going to 0, f x plus delta x minus fx divided by delta x. You have to remember this result. You have to remember this result, right? This is a result that is Very important to remember. This is the result. People, then if we need to find the dy by dx, directly we can use this one. Say in what? By the definition of the derivative. Writing like that statement, we write like this: dy by dx equals limit delta x going to 0. Right now, remember, tell me how to write this part within bracket. How do we get this one? In the given function, right hand side. What is this notation? Fx plus delta x means what, people? In the given equation of the graph, go to right hand side. On the right hand side, every x, for every x, you must write x plus delta x. Then what do you get? It is here. What is this fx? It is exactly the right hand side of the given function. Okay, that difference. Divide by delta x. Then after simplifying this numerator, you have to take delta x going to 0. Understood? Then you get finally an answer, that is the dy by dx. People, here, another thing you have to remember, this thing, fx plus delta x minus fx divided by delta x as delta x going to 0, this thing is denoted by another symbol, f dash x. It is called as the derivative of fx, f dash x, right? Also, you can write limit delta x going to 0, right? If x plus delta x minus fx divided by delta x. This is really f dash x. This is f dash x. What is this f dash x? That notation, derivative of fx with respect to x. Derivative of fx with respect to x, w dot r dot t, with respect to x. That also you should know. So therefore, people, whenever we need to find dy by dx for a given function, this one you can directly use. Dy by dx is equal to limit delta x going to 0. Remember the within bracket. What is the first thing? First thing is obtained. What is this? If x plus delta x, we obtain how, people? Given equation of the graph, go to right hand side. It's every x on the right hand side replaced by x plus delta x. Then what do you get? That is this. Minus the same right hand side of the given function divided by delta x. That's all. Remember that one, right? Okay. Any question here? Yeah, people? No. Then we'll write one example, another one example, right? Okay. Right. Find another question like this. Question: find dy by dx of y equals x cube. Find dy by dx of y equals x cube. Right. People, just try this one by using the things so far we did. Yes, people, who finished? Yes. Yeah. So this is people our fx now. Right. Then you can write by the definition of the derivative. What is dy by dx? Is equal to limit delta x going to 0 fx plus delta x minus fx divided by delta x like this. Now dy by dx limit delta x going to 0. Fx plus delta x means what, people? The right hand side is x, we have to replace by x plus delta x. For the letter x only, now we write x plus delta x. X plus delta x. Here we have 3, no? Power 3. Understood? Fx plus delta x means the right hand side, every x. For every x, we write x plus delta x. Then when you write x plus delta x here, power 3 we have there, x plus delta x to power 3. Minus fx. Fx means the same thing, right hand side, x cube divided by delta x. This here. Now see how to expand this a x plus delta x to the power 3. This is like a plus b to power 3. How to expand this, people? A cube plus 3a square b plus 3ab square plus b cube. That's how we expand. dy by dx limit delta x 1 0. Here x cube plus 3 what, people? X squared into delta x. You know this x squared and this x you can't multiply, right? And what is next, people? 3 into x delta x squared plus delta x to the power 3. Minus x cube divided by delta x. Right. Now we can do simplification like this. This x cube you can cancel down with this x cube. After cancelling x cube like that, you can see delta x is common to this numerator. You can take delta x out. That you can cancel down with this delta x. Then what happens? This delta x will vanish from here. Then this delta x squared will be delta x to power 1. This delta x cube will be delta x squared. And this delta x will vanish. Can you understand that simplification? Right? After cancelling this and this, delta x here we have, delta x here we have, delta x here we have. You can take one delta x out from a bracket from the numerator. That thing we can cancel down with that, with this. So there, if I write that in steps, we have to use another 2 more steps. No point of using people steps like that. Right. Now, here we have 3x squared. Here we have 3x into delta x. Here we have delta x squared. You know, in the limit lesson, when we find the limit like this limit we have to separately apply on each. Right, people? So then we write the next one like that. Dy by dx is therefore limit delta x 0. This now 3x squared. And next one, limit delta x 0, 3x delta x, 3x into delta x. Next one, limit delta x 0, delta x squared, like this. Now, next one, dy by dx. People, we said what? In the earlier first illustration, you could see this x, simple x, one change, though this delta x is going to 0. If this x one change, x squared one change, then 3x squared one change. This answer, this expression is 3x squared. But here, people, you can see This x won't change due to this delta x equal to 0. But though this 3x do not change, people, this one is delta x. This is the one going to 0 here. Then finally this will be 0. Then 3x multiplied by 0 means the answer is 0, people. Therefore, that is 0. Here, delta x squared inside the bracket we have delta x. This is only going to 0. Then when I put here 0, 0 squared is 0. This is also 0. Then we get 3x squared, right? All right. Therefore, dy by dx we get 3x squared. Right, people? But what is this y? Y equal to x cube. Then we can put that y x cube. Then this is derivative of x cube with respect to x dx equals 3x squared. So this is how we find the derivative of this x cube. Derivative of x cube going to be, people, 3x squared. Understood? Right. People, shall we take another one? Right, take the next question. Number 2. Y, find dy by dx of y equals x upon x plus 1. Right. The same method, people. Take this answer. Take this answer. Right, now here y equals x upon x plus 1. Now we write by the definition of the derivative. This is how we define the derivative of a function fx. Right, now we substitute. Right, what, people? Fx plus delta x means the right hand side every x we have replaced by x plus delta x. Then what do you get this one? X plus delta x divided by x plus delta x, this one plus 1, minus fx, the same thing, x plus 1. Divided by this delta x. Okay. Now here we do a simplification like this. People, soon after writing like this the definition, if you directly put delta x 0 for every delta x, what happens, people? You will get undefined form. In the limit lesson, right, we discuss how to substitute that value. Right, you know, when this delta x is going to 0, before putting 0 for delta x, definitely from the numerator and denominator, a certain occasion delta x term must cancel. Right? After that only we have to put. Until then, don't put delta x 0. Therefore, it says, people, certain extent, to certain extent, we have to simplify this. Right? This delta x is dividing this by delta x. No, that one I am writing 1 upon delta x. I am writing as 1 upon delta x. Right? People, dividing 4 by 2 means it is same as multiplying 4 by half. Dividing 4 by 2 means multiplying 4 by half. Like that, dividing this by this delta x means multiplying this whole numerator by 1 upon delta x. Okay. Then I can write it like this: x plus delta x divided by x plus delta x plus 1 minus x upon x plus 1. You see, we get. Now within this bracket, take the common denominator as the product of this and this. Whenever you take the product of this and this as your common denominator. By this x plus 1, you should multiply this. By this x plus 1, x plus delta x plus 1, you should multiply this. That way you have to simplify this. Right, come there two people. Then dy by dx. Limit delta x going to 0. 1 upon delta x. Take the common denominator as the product of this and this. X plus delta x plus 1 into x plus 1. This and this we multiply. X plus delta x into x plus 1 minus x times x plus delta x plus 1. This way, right? Now remove the brackets. dy by dx, limit delta x going to 0, 1 upon delta x, at this one, x and x squared, x and 1 x, delta x and x into delta x and 1 delta x, right? Here, x and x squared minus x squared, x and delta x minus x into delta x and 1 minus x. Divided by this. Don't expand this one, people. Keep that like that. X plus delta x plus 1, x plus 1. Don't remove the bracket to the denominator. Now simplify this. Right. Now this x squared and this minus x squared you can cancel down. People, this plus 6 and minus 6 you can cancel down. This x into delta x and this minus x into delta x also we can cancel down. Now see what happens. dy by dx, limit delta x going to 0, 1 over delta x. We have delta x here, divided by x plus delta x plus 1, x plus 1. People, we didn't cancel delta x on the right hand side from numerator and denominator yet. Now this is the time of the cancellation of delta x from the numerator and denominator. It is this delta x with this delta x. Here we get 1. Now we cancel down delta x from the numerator and denominator. Now this is the time to put what? Limit 0 for every delta x. Right. Now dy by dx, delta x 0. For that only we have to put delta x 0. Then what do you get? Numerator is 1. This is a place where we have delta x 0 because though this delta x 1 0, this x and this x 1 change, you know the reason. X plus 0 plus 1 come in first bracket, second bracket x plus 1. Right, people? Then this also x plus 1, this is x plus 1, therefore 1 upon x plus 1 squared. Right? Then d over dx, what is the function? Y, x upon x plus 1 is equal to what? 1 upon x plus 1 squared. It is the derivative of this function. It is the derivative of this function, people. Right now? Right. We come another one question. It is y equals square root of x squared plus 2. Y equals square root of x squared plus 2. Right. We will take this answer. Right. Now here, again, we can start from the definition of a derivative. Okay. Yeah. What is that, people, now? Fx plus delta x means what? The right hand side, wherever you have x, for every x, we write x plus delta x. That's the meaning. Huh? Square root of every x, we must write as x plus delta x. Here we have x squared, therefore x plus delta x squared plus 2 minus fx means the same thing, right? X squared plus 2. And this is delta x. Right. Now this delta x we write as before, 1 upon delta x. I open another bracket. It is the x plus delta x perfect squared plus 2 root minus root x squared plus 2. This way. Now, people, in the limit lesson, we discussed how to find the limit of this kind of expression having the square roots. There, I can remember, we used a certain technique there. We multiply this by its conjugate, and meantime we divide by the conjugate. Can remember that method? Huh? Yeah. Then we can use that here. dy by dx limit delta x going 0, 1 upon delta x. The conjugate of this mean, people, change in sign to opposite, what you get, that is called as a conjugate. X plus delta x perfect square plus 2 minus root x squared plus 2 multiplied by this x plus delta x perfect squared plus 2 plus root x squared plus 2. Divided by this x plus delta x perfect square plus 2 root plus this. Right. When you multiply this way by the conjugate, people, you know the way of simplified. There, when you take this as your a, this also therefore a. If this is b, this also b. Then here we have a minus b into a plus b. A minus b into a plus b means, people, a squared minus b squared. Right? Here we have factors of difference of two squares. Then you can write this as difference of two squares. What is that? Square of this minus square of this is the corresponding difference of two squares. Okay. So then we can write that one, dy by dx is equal to limit delta x 0, 1 over delta x. Square of this going to be the root will eliminate. X plus delta x perfect squared plus 2 minus x squared plus 2 divided by these people, x plus delta x squared plus 2 plus root x squared plus 2. Now, as I told earlier, people, until we cancel down delta x from numerator and denominator, don't try to put delta x 0. Why? Then you get one of the infinity forms there. 0 by 0 form will be coming. Then you have to make sure to put that delta x 0 after cancelling delta x from numerator and denominator. Then here the simplification can be done, people. dy by dx is equal to limit delta x 0 1 upon delta x. Right, expand these, people. X squared plus 2 times x into delta x plus delta x perfect squared. Remove the bracket by multiplying minus x squared minus 2. The denominator is x plus delta x perfect squared plus 2 plus root x squared plus 2, like this. Now let's see how to simplify this. Now the simplification can be done like this. This x squared, then this minus x squared you can cancel down. Another one I made mistake. This plus 2 I haven't written, people. Right, here we have to have minus sign. This plus 2 we must have here. Then this 2 and this 2 also you can cancel down. Understood? Now we'll write dy by dx is equal to limit delta x 0 1 over delta x into, here what do you have? 2x into delta x plus delta x perfect squared is the numerator. What is the denominator, dear students? Root of x plus delta x perfect squared plus 2 plus root of x squared plus 2. Now, so far we couldn't cancel down delta x from numerator and denominator, right? Now what can you do here, people? From this numerator, delta x is common. Take the delta x out. That you can cancel down with this. Then what happens is this delta x will cancel with this delta x, and one delta x will be remaining there. Now this is the time to put what? Delta x 0. Right. dy by dx. Now put delta x 0. Now delta x available, people, right? Shall I write that one again for clear? Clearly you can then see. Is now 2x plus delta x divided by x plus delta x perfect squared plus 2 plus root x squared plus 2, people. This is what we have, right? Now we have to put 0 for every delta x. Right, here we have delta x, therefore it is 0 because delta x is 0 now. Here also 0. We get, people, 2x numerator, 2x plus 0, denominator, x plus 0 perfect squared plus 2 plus x squared plus 2. dy by dx is equal to 2x divided by x plus 0 means x squared plus 2 root, here we have plus here root of x square plus 2. Then you can write 2x divided by this plus this means 2 times this x squared plus 2 root. No, correct? No, people, that this is like y plus y means 2y. No, and then this and this you can cancel down. Then you get the answer. What, people? D upon dx y. Y is that square root of x squared plus 2. Its derivative is now, people, this x upon root x squared plus 2. Understand? That is how we take the derivatives. Right. Now, people, using this way the definition of the dy by dx, finding this first derivative dy by dx is known as method of first principle of finding the dy by dx, or the definition method of first principle. First principle. Finding dy by dx using the first principle. That means directly using the definition of the dy by dx. First principle method. Right? Yeah. Now that part is over. I'll give you the tutorial, people. Then you can work out some questions. Right. Now we can come to the next one, a derivative of trigonometric functions. This using this definition, we can find the trigonometric functions, the derivatives of trigonometric functions. People, in finding these derivatives of trigonometric functions, we need that trigonometric limits results. That's also under limits we discussed. In addition to that, people, we need the trigonometric formulae, especially the CD formulae we need. So therefore, trigonometry we have done already. Everybody has done. Then those formulae are very important. By the next class, people, that will be very useful. Therefore, you have to remember that trigonometry formulae, right? Don't always try to copy that your short note one, because one time at the examination, you will be not allowed to copy that note. So therefore, everything must be in your memory. So therefore, gradually, you have to memorize all the formulae. Right. Now we can come to, people, the next subbit in write down derivatives of trigonometric functions. Derivatives of trigonometric functions. Write down derivatives of trigonometric functions. Derivative of trigonometric functions. Right. First one will take number 1, y equals sin x. The fixed right hand side function is now sin x. Y equals sin x. Y equals sin x. Right, now we write the definition of the derivative. By the definition of the derivative. What is that? dy by dx limit delta x going to 0 fx plus delta x minus fx divided by delta x. What is this fx plus delta x? The right hand side, every x we have replaced by x plus delta x. dy by dx is limit delta x 1 0. Here sin x plus delta x minus sin x divided by delta x. Right. Now people here, we apply the CD formula, assuming this x plus delta x angle as C and this x angle as D, then there we have sin C minus sin D. What is the formula for sin C minus sin D? Sin C minus sin D. Sin C minus sin D. It is 2 cos, no? C plus D divided by 2 into sin C minus D divided by 2. That we can apply here. This delta x I write as 1 upon delta x. dy by dx limit delta x going to 0 within bracket 1 upon delta x I write. Here we apply 2 cos. Right. C plus D divided by 2 means what, people? C plus D divided by 2 means sum of these 2 angles and divide by 2. When you add these 2 angles, what do you get, people? X plus delta x plus 6. What is that? X plus delta x plus 6 divided by 2, no? X and x 2x plus delta x divided by 2. Dividing this 2x by 2, we get x. Delta x divided by 2 means delta x by 2. So therefore, I write in the latter case directly this kind of sum, right? Then adding this and this dividing by 2 means, people, x plus delta x by 2 come in. Secondly, sine come in. This minus this, then x and x will cancel off, because the second case is what? C minus D, no? C minus D by 2. That means this should be subtracted from this, then x plus delta x minus 6, right? X plus delta x minus 6. C minus D divided by 2, no? This and this you can cancel down. There we get delta x by 2. This one we get. Okay. Now, people, I do next thing like this. Right now, I think up to here you can very clearly understand. Right, up to here you can do. Right now, here I do another few steps in one. It is this. First, I write sin delta x by 2 this way. The angle is delta x by 2. Right. Now, this delta x, by this delta x, we have to divide this product, no? When we divide this kind of product by something, no need to divide all the terms in that by that one, because there we have a product. Only one is enough. Therefore, this time I am going to divide this thing by delta x. Right. Now, this 2 is there, people, and cos x plus delta x by 2 also there. Right. Now, What I do is next this. I write 2 here, delta x below the delta x. We can't write like that in number, we like everywhere, no people. Then dividing this delta x by 2 to cancel down this 2, I write before this delta x another 2. Then this 2 and this 2 will cancel off. Nothing will happen. The same expression only still we are having. But this 2 we can cancel down with this 2. Now here we have form delta x by 2 divided by delta x by 2 form. Why? The reason, people, under limit lesson we learned sine theta divided by theta as theta going to 0 going to 1. In this case, that theta is this delta x by 2. In order to form that, form sine theta by theta only, we did like that. Now this limit delta x going to 0, we apply here and here both separately. Limit delta x going to 0, and here also limit delta x going to 0. Understand? Now here you have delta x. When this delta x going to 0, this is 0. 0 divided by 2 is 0. Then we have within bracket x. You know this x1 change due to that delta x going to 0. Then this is cos x. Then dy by dx is cos 6 into, here people, delta x going to 0 means half of delta x also going to 0, no? Delta x going to 0 means delta x divided by 2 also going to 0. If you take this as theta, delta x by 2 as theta, this takes sine theta divided by theta. Delta x going to 0 means delta x divided by 2 also going to 0. Then here we have limit theta going to 0 sine theta by theta. It is what, people? 1. It is 1. The reason you can write, because as limit theta going to 0 sine theta by theta equals 1. Then we get this one as 1. People, this whole thing as 1. That one only here I wrote. Now we have cos 6 into 1 is people cos 6. Right? So therefore, the derivative of what is y? Y is sin x. Derivative of sin x with respect to x is people cos 6. This is the result that we need. Understood, no? This result you learned where? In the limits, right? Right. Take the result. Right, people? Got this? Right, no? Right, we'll come another one. It is y equals cos 6, the second one. Take, people. Next one, y equals cos 6. Y equals cos 6, number 2. Take the second one as y equals cos 6. Right, start this, people. Right, now here we write what? Cos x plus delta x minus cos 6 divided by delta x. Right. Now here you can apply cos c minus cos d formula. Right. Cos c minus cos d. What is the formula, people? 2 sine c plus d by 2. The second ratio also sine, no? Sine d minus c divided by 2, right? cos c minus cos d, 2 sine c plus d by 2 sine d minus c by 2. Right. Then here, this is your c. This is your d. This delta x we write as 1 over delta x like this. 2 sine. At this angle and divide by 2. What do you get? X and x, 2x. Dividing by 2, we get x. And here delta x also we have divided by 2. Delta x by 2. The sum of this and this only we have divided by 2. This is what we get. Secondly, sine d minus c. From this, we have subtract this. X minus x plus delta x. What is that, people? X minus x plus delta x. This and this you can cancel down by removing the bracket. Multiply minus sign. This will be minus delta x. Then there we get minus delta x by 2. People, in trigonometry we learned whenever we have minus sign in the angle, having sign before that, that minus sign you can take out. This kind of result can remember. Sine minus theta is equal to minus sine theta. Not only here the sign, but tan also, if we have like this, that minus sign you can take out. But when you have cos, people, we said, but this minus sign you can't take out. Cos minus theta is written as cos theta, right? So this minus sign, therefore, people, I can bring where here. That one we can bring to before. Why? Minus sign means minus 1. Minus 1 never change due to this delta x equal to 0. Minus 1 is always a fixed value. Nobody can change that size of the minus 1, right? So therefore, that minus sign you can take before this. That one you can bring before this, right? So now we get dy by dx now. Minus sign I write here. Right. Now here at once we arrange in one step the things that we have to do 2-3 steps, right? Right. Here this minus sign we have taken out now. Then we have sine delta x by 2. Right? Okay. Now this delta x I can bring below the sign. Now people, as before, what I do, we here divide by 2. Don't write this on, people, now. And here 2 I write. This 2 will cancel off. And another 2 here we have now. That 2 when I write here, this 2 will cancel off. Then people don't write that also now. This is what we get finally. Now this 2 also we have used. Then here we have sine x plus delta x by 2. Right. Now we have to put limits, people. How? This limit delta x equal to 0, we have to put here and here separately. Like this. Understood? Now put delta x 0. People, here, when you put delta x 0, 0 here divide by 2. This is 0. Then we get only x within bracket. Then we get sine x. But we have minus sign before that. dy by dx is minus sine x. Right, people? Now here, delta x by 2. Here also delta x by 2. We take this delta x by 2 as theta. Then what we have here? Sine theta divided by theta. Delta x going to 0 means half of delta x also going to 0. Then delta x going to 0 means delta x divided by 2 also going to 0. Then what do you get here? Delta x by 2, if we take as theta, limit theta going to 0, sine theta divided by theta. That is really, people, 1. So therefore, no need to explain here, as delta x going to 0, delta x by 2 also going to 0. Those things, of course, not that much interest there, people. Everybody knows that delta x going to 0 means delta x by 2 also going to 0. So therefore, we directly put this as 1. And we ensure to write the reason here, because as lim theta going to 0, sine theta by theta equals 1. Then here we get minus sine x into 1 is, people, minus sine x. So then derivative of cos x is right minus sin x. This is our the second result. You should know, people, how to prove this result. Sometimes they may be asking at the examination to prove. Okay, right, come to the answer.